Good day everyone, welcome to this presentation titled, Toxic Fog, the Contaminated Table, When Nourishment Becomes Exposure. I'm Dr. James Joseph, and I'll be guiding you through our findings today. The time to act is now, friends. Time is running out. Before we dive in, a quick disclosure: the following images and information represent our interpretations based on independent analysis and comparisons with published research. This is presented for educational and collaborative research purposes from the LEXX Research Medical Center. Let's start with some case presentations. Patients have reported symptoms like, "When I eat food, it feels like poison is going to my head." Others say, "I am itching all over. At night, it feels like something is biting my legs." One mentioned, "I was able to control my fibromyalgia with a strict diet for years, and I'm flaring up for no reason." We've heard similar complaints across the country and internationally, which recently raised our suspicion of a shared environmental or systemic exposure. Here's a patient photo during a Woods lamp exam that I conducted. Moving to our microscopic findings, we've examined multiple grocery food sources, including organic, frozen, and conventional items. We consistently found the presence of foreign structures resembling spores, filaments, or parasitic forms. Tap water showed similar particulate forms. Even supplements, including high-grade and imported ones, displayed the same recurring morphology. This suggests possible cross-contamination across global production lines. This photo is from tap water. Now, let's look at blood samples. In our blood samples, round rigid unidentified microstructures are a common finding, observed at 40x magnification. These require further taxonomic or chemical characterization. Here, foreign structures resembling spores were observed migrating and congregating outside the cover slip. This happened after a microdose of diluted powdered Ayurvedic herbs, Holy Basil and Neem, was applied to the blood sample under light microscopy at 40x magnification. Next, food samples. In gluten-free bread, we observed foreign structures morphologically consistent with spore-like, filamentous, and parasitic forms at 40x magnification under light microscopy, based on independent analysis. In tea fannings, foreign structures morphologically consistent with spore-like forms were seen at 40x magnification under light microscopy, based on independent analysis. Now, supplement samples. In a lion's mane mushroom capsule, foreign structures resembling spores, filaments, or parasitic forms were observed at 40x magnification under light microscopy, based on independent analysis. In whole bean coffee, foreign structures morphologically consistent with spore-like or filamentous forms were observed at 40x magnification under light microscopy, based on independent analysis. In a sublingual activated charcoal formula, spore-like structures were observed at 40x magnification under light microscopy, based on independent analysis. These findings raise important questions. Are we witnessing microparasitic persistence, such as spore or cyst forms of chronic Lyme-like organisms? Could these be biofilm fragments or nanostructures of industrial or environmental origin? Might agricultural nanotechnology or biopolymer coatings be an unrecognized factor? Are hydrogel-based food stabilizers or packaging residues contributing to the visual findings? This photo of ground coffee was taken by me. Turning to innovative research solutions. Home-processed holy basil, Ocimum sanctum, and Neem, Azadirachta indica, leaves were air-dried and encapsulated for standardized daily dosing. Within 24 hours of the first dose, microscopy showed improved red cell mobility with thinner, distorted spore-like structures. After 48 hours and 2 doses, the overall presence of these forms, based on independent analysis, appeared markedly reduced. Another innovative approach, based on independent analysis, apheresis, via direct removal of plasma and filtration, can improve red cell mobility and reduce the amount of spore-like structures observed in blood samples under light microscopy. We are at a crisis point. The evidence emerging from blood, food, water, and supplements can no longer be dismissed as coincidence or contamination alone. These findings demand rigorous investigation. We are standing at the threshold of a potential environmental and biological crisis, one that will not correct itself through silence or disbelief. This is not a plea for attention, but a call for qualified minds to engage. The data will speak for itself, but only if we are willing to look directly at it, together, before the opportunity to reverse this trajectory is lost. For nearly a year, the team at LEXX Research Medical Center has worked day and night to better understand the science behind the microscopic phenomena we are witnessing. LEXX Research Medical Center is a non-profit, humanitarian clinic devoted to investigating the mechanisms of emerging environmental and biological stressors and their impact on human health. Our mission is simple yet urgent: to relieve suffering for those seeking answers when conventional pathways provide none. The LEXX Research Group is a collaborative community of more than 25 physicians, scientists and independent researchers who voluntarily contribute their time, intellect, and resources to analyze complex medical cases, review microscopy findings and interpret scientific literature. All efforts are undertaken solely for educational and humanitarian purposes, with no commercial interests, to encourage collaboration and bring clarity where uncertainty remains. For inquiries, scientific correspondence, or to contribute to this ongoing work, info-view correspondence lexresearch.org, visit our website, lexdoctors.com, as well. A note on our methods for light microscopy preparation: fresh food and supplement samples were mounted in saline on sterile glass slides. Capillary blood was obtained by sterile fingerprick using a single-use lancet and mounted fresh for live microscopy. Images were captured using 40x objectives with light microscopy, digital imaging. Environmental controls included room temperature of 23 degrees Celsius and ambient humidity. Finally, here are our references.